Welcome to a lesson with Dr. Powell. Let's talk about how we can find the maximum or minimum y value of a quadratic function. Now, what is a quadratic function? It's simply a function whose expression has a x squared in it and an x and maybe a constant term added together with coefficients, such as something like this: 3x squared plus 12x. And maybe we have something like plus 7. Okay, so this is a quadratic function. Now, a quadratic function can actually be thought of as a transformation of y equals x squared. We might have to complete the square, though, so we can see exactly how it's a transformation of this. But thinking about that, it's a parabola. And parabolas either have a maximum y value or a minimum y value. So we're going to be investigating that and deciding what y value is the maximum one and or if there's a minimum, what one's the minimum. Also, we want to figure out where that happens. That's at an x value. So the what is the max or the min y value, and the where is the x value. So x equals what? So pretty much what we're looking for is we're looking for the coordinates of the vertex. If we can find the coordinates of the vertex, the x value will answer the where, the y value will answer the what. So that's pretty much all we need to do. So if we think about this as being a transformation of this over here, we think the original vertex is at 0, 0 of this parabola right here. So we just need to know what the destination of 0, 0 is in the transformation that takes us to here. So let's get started and complete the square here to see what that transformation will be. So you see this constant? Let's just put it off to the side for a minute, and we're gonna focus on everything else and factor the coefficient of x squared out of everything else, so that there's a 1 in front of the x squared. Okay. Now we're just going to concentrate right in here. We're just going to not worry about anything outside for a minute. We're just going to focus right in here and complete the square in a similar fashion to what we've done before. So we take 1/2 of this 4, and we think x plus 2 quantity squared. Now, in order to take this and replace it with this, requires us to add something. In fact, if you take this 2 and you square it, that's what you're adding. And you can check x squared plus 4x plus 4, just like that. X squared plus 4x plus 4 is actually equal to x plus 2 quantity squared. You could try it out, multiply it out, FOIL it, you'll get this. Now, but in making this replacement, we added 4. So basically we're adding 4 if we say that, but we don't, but in this particular bracket, we want to offset that. We want to put a -4 right here because we want to basically have this bracket be the same as what's down here. So if we've added 4, we better subtract 4 so that we've essentially done nothing to this. So it's still x squared plus 4x. We still want this to be equal to x squared plus 4x. Since this is equal to x squared plus 4x plus 4, we better put a -4 here so that this is still x squared plus 4x. I mean, you could try it out if you want. Multiply this out and check and see and verify that this right here is actually still equal to that. Okay, so basically what we can remember, though, is we make this replacement and then we put the minus of whatever this would be. So we take the minus of this squared. So this will actually always be a negative, always, because you square whatever this is, it's positive, and then you just make it negative over here. Okay, so we make that replacement, and that's pretty much almost it. Now we just distribute this 3 to both parts here across the subtraction, And we have 3 times quantity x plus 2 squared minus 3 times 4 is 12 plus 7. So we end up getting 3 times quantity x plus 2 squared minus 5. And that's what y is going to be equal to. So you notice this looks very nice because it is a transformation of y equals x squared. And so we can think, where is 0, 0 going to land? Okay, well, let's think about the transformations here. For the x transformations, there's just one thing done. Subtract all your x values by 2. So 0 moves to -2. What about for the y? Well, you take your y value, and the first thing you do is you multiply it by 3 to get you 0. Then you subtract 5 to get you -5. So the destination of this vertex is that one. So this tells us the where and the what. Now, is this a minimum or a maximum, we should ask ourselves? Well, this is a transformation of y equals x squared, which has a minimum. The only way for it to become a maximum is if there has been a vertical reflection or reflection about the x-axis. Now, looking at the y transformations, the only way that could happen is if there were a negative right here for a reflection, but there's not. Therefore, it'll stay a minimum. So we know it's a minimum. The what of the minimum is right here, the -5. The where of the minimum is the -2. So what is the minimum? The minimum is y equals -5. Where does it happen? At x equals -2. Thanks for watching.